perpendicular. So
Okay.
Wait, in this case, do you have like a big binder clip? Or like a medium one?
perpendicular is the other way, so it'd be right here.
Okay, let's talk about segments in triangles. We are going to start out with a perpendicular bisector of BC using a ruler.
So you'd go from the top of A down.
Okay, we're not going to go from A. What we're going to do is we're going to look at, focus in on BC. If it's going to bisect segment BC, you want to try to figure out where the midpoint would be.
Oh, it has to be exact?
It doesn't have to be exact. If you want to use your ruler and measure it, that's fine. But
Wait,
I would
wait,
just
wait.
say kind of eyeball it.
What?
So just kind of like look.
The bisect, so split.
Oh, the bisect.
Okay, so how do we note that that's the midpoint?
Because it's
So it's in the middle.
Okay, but how do we,
Because
they're in between.
how can I
Point.
label something so that I know
You can do
this and this? Like
Oh,
a
yeah,
little
congruent
line?
lines. Wait, does it have to connect to the A?
No. In fact, it's not going to.
What do you mean connect to the A? Oh,
Like as a
Okay, now what we want to do,
Oh.
hold your ruler, okay? Let's put it right where the midpoint. And if it's got to be perpendicular, do we want to connect it to A? Will that make it perpendicular? That's not a
No.
90-degree angle. So instead, I want to hold it like this and draw the line through it that way.
Is this a new? This is new, right?
This is new. This is what we call the perpendicular bisector. So I'm going to draw a line. You'll see it.
Flashback for it?
Down on the actual.
Oh, fine.
But I thought whatever bisects, it has to be like.
Okay, so it's just bisecting the side. In other words, we
Oh.
ignore all of the other segments. Now, how do we show that this is perpendicular? What do we have to add to our drawing?
Right angle.
A little
like thing.
thing, a little
Because
box.
the line is like going into the line of the ball. Oh.
Like that. Well, we want to show these two are congruent, and we show that that's a right angle.
Wait, why did I have to
Oh,
go?
you put the line in the middle. Oh wait, how do you know where to put the line?
So it's got to go through the midpoint. So
How do you know the mid? Oh, when it's asking for.
yeah, so here, perpendicular bisector, the definition, it's got to be perpendicular, and it's got to divide it into two congruent segments. Okay? So here's another picture. So do you see PQ? PQ is the perpendicular bisector of KM. How do we know? We see these two segments are congruent, and there's a little square. Just I would just write out the definition and maybe draw a picture. Okay.
Wait,
Wait, so it's.
So a perpendicular bisector is a segment. It could be a ray or a plane, but I would just say it like it's a line.
Now that it's like second semester and we have tests to give us that like paper, like all of those things.
Yeah, I'll still do that.
Do we like cancel out all of the ones from first semester?
I build on top of the ones from the previous,
Wait, what?
because as we know in math, a lot of the topics are going to build, like we're going to do parallelograms in the next chapter, but parallelograms can be split into two triangles. So remember all the theorems like side, angle, side? We still have some of those.
Side, angle, side.
Yeah.
Angle.
Right, so we still have some of those ideas that we're going to use second semester. All right, good to go? And it seems like we have a lot for this lesson, but the second lesson is like really short. Okay. We have perpendicular bisector theorem and the converse. Okay, so what does this say? If you have a point on the perpendicular bisector, right? So what is the perpendicular bisector here? It's CD. What is it bisecting? AB. So if this is true, we say that the point is equidistant from the endpoints. So let's say C. What does equidistant mean?
Equal distance.
Equal distance, right? So it's saying C is the same distance to A as it is to B. So in other words, what ends up happening,
So that's the midpoint of.
yeah, so this is the midpoint, and basically it makes these two segments congruent.
Wait, is this all on one flashcard?
I would say, why don't you just do one? You don't, just do the flashcard for the first one. So only do the flashcard for this one. Don't worry about the converse.
How do I? Never mind.
What's wrong? Just say that basically what ends up happening is you make what kind of triangle? What kind of triangle would we call ABC?
And isosceles.
Why is it isosceles?
So there's two congruent sides.
Because we have two congruent sides here.
Well, we have 3 congruent sides. Because C, D.
Right, but what I'm saying is these two, what do we know about this little triangle and this little triangle? They have to be congruent, okay? Now, we will have some proofs second semester, but not nearly as many as we had first
Is
semester.
it always an isosceles triangle?
If it's a perpendicular bisector, yeah. I don't know, I'm doing a recording, just, I don't know if he's out sick or,
He left.
no, he's still on the
No.
roster.
Jason, Jake saw. Oh yeah, what's Jason?
Okay. Are we good?
I missed him.
Oh,
Okay.
okay. Surgery.
Oh no.
Solve for
Is this
x.
a
Vocal cord surgery?
Okay.
Gosh.
Guys.
Solve for x and RT if SR is a perpendicular bisector. Okay. What did we just say when we have a perpendicular bisector? It makes what kind of triangle?
Isosceles.
Okay, so if this is isosceles, which two
2x
segments?
plus 3 equals 4.
Yeah, we're just gonna make these two equal to each other. So 2x plus 3 equals 4x minus 7. So go ahead and solve. What do we get? Ladies, Sienna,
5.
what do we get for this? Samantha,
We got
remember, we talked about seat changes if we need.
Wait, 10 over 6.
I got
Is that not right? I didn't get a whole
Equals
number.
5.
I got 5.
I did it wrong.
Oh, okay, so we should get x equals 5.
And
And
then
then,
RT equals 13.
how do we get RT?
Because you plug it in.
Right. So 4 times 5 minus 7. Okay, so we get 20 minus 7? 13. Now, if you want to check your answer, we could also plug 5 in here, and we should get the same answer, right? 2 times 5 is 10, plus 3, checks.
So you just plug in it.
Yep.
But where do you find the 5?
You set the two parts equal to each other.
Oh, so perpendicular bisector makes
A perpendicular,
each other?
yeah, perpendicular
Oh,
bisector
so two
makes
things
it,
are being split equal?
exactly.
So you take the two equations and just.
You do 2x minus 10 plus x.
Okay,
Plus x plus
if
5.
this is a perpendicular bisector, we want to find x and y. Well, these two have to be
Equal.
equal.
And then can you do 4y plus 6 plus y equals 90? Because it's
Yeah, 4y plus 6 equals, yeah. So we're going to do 2x minus 10 equals x plus 9.
Dude, where'd you get 90? Oh, because it's above the six.
So do we get x equals 19? Now, again, if this is the perpendicular bisector, perpendicular means what kind of angle?
right.
A right angle. And if this is a right angle, it's got to be equal to 90 degrees. Okay, so subtract 6, that gives us
84.
84, so y equals,
22. No,
close,
21.
21.
Wait, which ones do you set equal? X plus 9 and 2x minus 10?
Yeah, why do we set those equal to each
Because
other?
it's perpendicular.
Not because it's perpendicular, because it's, what's the other part of the word?
Oh, but
Bisect. So we set these equal to each other because it's a bisector. Bisector cuts
That's
it
what I
right in
meant.
half. And then this we set equal to 90 because it's perpendicular.
Wait,
Is that equal to 90?
The angle.
did we make it? How did we get 9?
Yeah, what?
What's perpendicular make? What kind of angle?
Right. Okay.
And how much is the right angle equal to?
Wait, you said what equal to 90? I don't get it. Or, oh, because it's complementary? No.
It's 90
No,
degrees.
Right angle. But why do you put it, like, why do you have it?
We make it equal to 90 because it's perpendicular. Perpendicular makes right angles,
Okay.
right? Do you remember that definition of perpendicular? Okay.
No,
All right.
kind of. I lost all of my brain knowledge. while it
Well,
was ago.
let's bring it back. Okay, next, what we want to do is we want to draw an angle bisector. And this one, ignore the protractor, we're just going to use our ruler to try to figure that out. So we're going to draw the angle bisector for angle B. Okay, so now we have to start from the vertex. Take your ruler, okay, and line it up with B. Now, I want to try to angle the ruler so it kind of cuts it right in half so that the two angles look equal to each other. And then go ahead and draw. Oh,
Wait, so what do you mean?
Wait, but why are we starting at
We make it diagonal?
B this time?
because this is a different
So we make it
segment.
slightly diagonal?
Yes,
Not slightly, a lot diagonal.
a lot diagonal.
No.
I think Max Winter is having a little bit of a struggle. Why? Because you were like saying,
Okay.
I don't know.
Are you getting like paid to talk?
Okay. How do we know
A-
it's a bisector?
A something is congruent to C whatever. Or I mean B.
Don't even worry about those.
BA.
We're just looking at angle B,
Okay.
and we're going to cut angle B in half. How do we say that? How do we mark the two angles congruent? You put like the little arcs.
Oh.
Now, here, are these two necessarily equal to each other?
No.
No. So we're not going to label those
Wait,
congruent.
how?
It's just bisecting what?
The angle.
The angle. Is it bisecting? Does it say anything
So
about
those two
bisecting
aren't
this?
congruent because
They're
it's
not.
bisecting the segment.
It's not bisecting the segment. It's only
angle.
bisecting
So
the
it's like-
angle.
so it's not
perpendicular.
There's no perpendicular
it's
here.
angle.
It's just an angle bisector. Okay, so this is the definition of an angle bisector.
Didn't we do that?
We did. This was, some of this terminology should be familiar from last semester. So this divides the vertex into two congruent angles. Okay. So here's just another picture. All you need to know about an angle bisector is when the angle is divided into two smaller congruent angles.
Yes.
But it doesn't make any of the segments, so there's no, it doesn't make the opposite. This is not necessarily the midpoint here.
But I thought we already learned angle bisector.
We did, but we didn't do angle bisectors, like
Triangle.
with, we didn't do any theorems on them or anything. You'll see, you'll
Now
see.
we're having a whole theorem.
Yeah, but it's easy.
Is this semester harder than the other one?
You're basically set, you either set things equal to each other or you set them equal to 90.
Oh, so it's equal to 90 if it's like
Perpendicular.
If it's equal to each other if it's like
Bisector. That's all you need to know.
Okay, great.
So you see the word bisect? You're gonna see that they're equal to each other, the two
Yes.
small. And if it's a perpendicular, you're gonna know that it's equal to 90.
Great.
Okay. All right. Again, don't worry about doing a flashcard. Just do the flashcard for the first one. Okay, if there is an angle bisector and there is a point, so if there's a point on the bisector, it's equidistant from the sides. So in other words,
Wait, so does that mean like, wait, can you go up to the other one? So like, does that mean that BD and DC are equal?
No. Okay, so you have to make sure if I want to, let's say from D, if I want to draw the distance from D to AC, I would want to draw it straight down. Does that make sense? Right? So I
Actually,
would
not
say, I would draw it like this. And then I would do the same thing here.
Wait, why is it?
And then these two are congruent. Because if I were to measure the distance from D to this side, I would make it perpendicular. Okay, all you need to know, right? Sometimes it's helpful to draw it from scratch. Okay, so if I drew an angle,
Are you just showing an example of the angle
I'm just gonna show you. So let's say this is my angle, and I want to bisect it. So I'm gonna go like here. If I pick any point, let's say this point here, and I draw each side, like if I want to measure from here to here, I'd go straight down, right? And if I want to measure from here to here, I go straight over. What can we say about this segment and this segment? They have to be equal to, they'll always be equal to each
Okay,
other.
but even if it's like, if you want to measure from like that point to like much higher up, would it still be equal?
Yeah.
Or does it have to be?
So if I
like,
measured here, and I measured over,
No, that's not really what I.
that's not what you meant?
No, like let's say like you measured one, like just going straight down, and the other one.
No, they always have to go perpendicular. Okay?
What page are we on?
We're on page 3. Okay. All right, AD is what kind of bisector? An angle bisector. If AD is an angle bisector, what two angles are going to be the same?
The top two.
The top two. So I'm going to just put here and here, okay? And what am I looking for? I'm trying to find measure of angle ADC.
Well, you could just do a big, oh wait.
Okay, what I want you to do is ignore the angle
Oh,
bisector.
You could do a 66 plus a 50.
Oh, yeah, because A
equals a
equals
180. And then you put
180
that,
minus
and then you
160.
divide it by.
Could you
don't you just do 180?
No, you could do 66 plus 50 plus 2x.
That's what I just said. And then you divide it by 2 once you.
Oh, you could do that too.
And then you put that. And
Wait, can you
do
show us the other options? I don't
whatever it is.
understand that.
plus
They're
50
saying this.
equals
I could do 66 plus 50 plus 2x.
Why 2x?
Because it's 2 things that we
Because
don't know.
this is x and this is x.
But can you show us the one you were going to tell us?
Yeah.
Just add the bottom together and
If
then
this is,
subtract it from
if these
180.
add up to 116, then this whole angle has to be 64.
Oh, I thought it was 7.
A big 64 divided by 2.
So each of the smaller ones ends up being
32.
32. If I set it up this way, I get the same answer.
Then you do 32 plus 50 plus x equals.
Wait, what do you mean by
Hold
smaller
on, can you write your
Oh.
down?
I did. The way I did it is I just figured out this part by looking at the big triangle.
Oh, and then you find that angle.
And then you can find each of the smaller
So it would
angles.
be 164.
Okay, now,
So x is 30. Wait,
yes.
I don't get your way. Can you explain your way?
All you have to do is
You see the big triangle? Ignore the angle bisector. These 3 have to add up to 180.
Is the whole.
So 66 and 50 add up to 116. If I take 116 from 180, I get 64.
Wait, so angle. So it would be 64 equals 32.
Okay, so I get 32 degrees for each of these. But what am I actually looking for here? Which angle?
Oh, that.
I'm looking for this one. Could I ignore the little triangle on the left?
Yeah.
And then what? Do you see it?
32 plus 50.
Okay, 32 plus 50 gives us.
82.
So 180 minus 82. Does that make sense?
So
In the
it'd
back?
be, so it'd be like 98.
Where's 82 from?
These two added together. See this triangle here?
Yeah.
If I know this is 32 and this is 50, those add up to
Well, why do we
82.
subtract? So what is it?
Because
98.
what's the whole triangle? What's the triangle have to add up to?
180.
So the measure of the
180.
angle is at the vertex.
But if we subtract 82, then it
Then
equals
that-
98.
Yes.
Not 180.
Right, that's what I want to have for here. Measure.
Oh, and then that's how you can find D. You would do. Okay.
Okay.
Oh my god, this is so simple.
What's wrong? Only second period. Okay. What's this mean when the two little arcs are here?
Angle bisector.
It's an angle bisector. So, what are we going to do with measure of angle 1 and measure of angle 2?
Make them equal.
Remember, most of the time, with something like this, we really only have two choices. We're either setting them equal to each other, or we're setting them equal to 90. But would setting them equal to 90 make any sense here?
No.
No, there's no
The
right
only
angle.
Angle is being, like the angle is being bisected.
Right, the angle's being bisected. Do we see the word perpendicular anywhere, or a right angle? No, so we don't bother with that. Okay, let's see, add 16, subtract 5x. What do we get for x? Perfect.
And that's when you make them equal too, right?
Yeah, we've got an angle bisector. So these two segments have to be
Equal.
equal.
For the angle bisector, how would they be, wait, which two segments?
These two segments have to be equal. That was the angle bisector theorem.
Those two angles have to be equal?
Well, the angles are equal,
I got a fact.
Me too.
and these are equal.
Me too.
Okay, listen, angle bisector, no matter what, you're just gonna make them equal to each other. Like, anytime you see the word angle bisector, make them equal.
This doesn't.
Did you get a fraction? That's okay.
Yeah, I got x equals 7/2.
Perfect.
I thought for angle bisector, it doesn't make the two segments on like the other side of the triangle equal because it's only,
Oh,
like,
that's talking about AD and CD. These aren't equal.
they could be. We don't know.
They could be, but we don't know. Okay.
Uh-oh, we're starting a new one.
Yeah, but this is short.
Oh wait, they don't want to.
Yeah, we're doing 2 today. Oh my goodness.
Oh,
This case is so mean.
it is short. It's like one
That's what I said, it's short.
page.
Okay, median. New word.
Median something in
it's
mode.
the-
I remember this.
Oh my god.
Okay, you're thinking median when it comes to algebra or pre-algebra. This is different. Okay, a median is basically a segment with endpoints on the vertex and the midpoint of the opposite side. Okay, so take a look. Here's CD. It goes from the vertex to the midpoint. This is the midpoint.
But we just did that.
Okay, we did angle bisector,
Oh, yeah,
Oh, we-
no, but like when you told us like
but it's the same thing. Okay, now, this is not an angle bisector. Do these two little angles look congruent?
Yeah.
Wait, this one looks a little bit bigger. So a median only tells us that we have a midpoint on the opposite side. So think median, midpoint.
The median of ABC.
I would say like 4 times out of 5, we're just gonna set the two parts equal to each other in these two lessons.
Yeah.
The other prime equal to 90.
So this one
Okay.
you just set equal to each other.
Wait, I don't really get it.
Take any triangle. Okay, let's say here's triangle ABC. If I wanted to draw a median,
Wait, can it be a scaling?
yeah, of course.
It could be any type of triangle. Could it be any type of triangle?
It could be any kind of triangle. So if I wanted to draw the median from angle B, it has to go from B to what on the opposite side?
Midpoint.
So I have to find the midpoint
And that's already there.
and then draw it. That's all.
Wait, what's the vertex again? I totally forget.
The point where, like, it's in the middle.
The vertex is just where the two sides meet. So like here, what's the vertex?
Oh, just A.
It's
Oh,
A.
alright, yeah.
So if A is the vertex, what is D? The midpoint.
Yeah,
So
okay.
that makes what two parts equal?
4x plus that is
Perfect, right? Okay, so we're gonna set them. Samantha,
what?
what are we gonna do?
Wait, how do you find AD?
For that one? Well, I can't see.
Come on.
You're gonna
Well, I already
set the
did it.
angles equal to each other.
Right.
Like, you can't set those two segments equal to each other. So I don't really understand.
It's
what we're
5.
Yeah, we can set them equal to each other. What do we know?
doing. No, but how do you know that those two segments
X
are
is
equal to
5.
each other?
Because a median goes to the midpoint.
Oh, I can see
Shower.
D. But how do you know that a D is in the median?
I just got it.
Wait, but how do you find?
It tells us.
Oh.
How do you find AD?
No, you don't have to find AD.
Oh,
I
eight.
It just says if
I
AD.
don't
No.
I thought I said find.
You scared?
I don't wanna
It's K0. Because AB is like half of it, and then DC is the other half.
Also, I have highlighted.
I'm really getting it out.
I haven't been thinking about
Okay, altitude. See, we'll still finish early and we can start the worksheet. Okay, have we heard altitude before?
No.
Yeah.
Well, yeah.
Yeah.
Yeah, what's altitude?
A ski
How
lift.
high?
It's
A
like
ski
that.
How
lift.
high something is.
How high
It's
something
AC.
is. So when we think of altitude, right, like an airplane is flying at 32,000 feet altitude, right? That's how high it is up in the air. So the altitude of a triangle is the height. That's all.
Is that all we have to write? Just the height?
Yeah, I would just say,
The height of triangle.
yeah, it's the height. Now, what I need to make sure, when you draw the height of a triangle, what does it always have to be? Like if I wanted to find the height of the triangle here,
In the middle?
Oh, it needs to be from the.
would I draw it here? Would I draw the height there?
From vertex to midpoint.
No, from vertex to just down.
And what kind of angle does that
Oh,
make?
perpendicular.
Okay, so whenever I have the altitude, I always want to make sure it's from the vertex
And it's always.
and it has to go perpendicular to that side,
What?
opposite side, the opposite side. Okay,
Wait,
so,
what do you mean? Perpendicular to the opposite side.
okay, so let's look at this triangle ABC. If I wanted to draw the height from point B, would I draw it sideways?
No.
No, I want to draw it straight up and down to make a right angle. Okay, now this is an obtuse triangle here, ABC. If I'm looking at B, can I draw a perpendicular segment to the opposite side? Let me show you a different picture here. Okay. If I want to draw the height of this triangle, if I'm trying,
Straight down.
can I draw a right angle
Don't you just have
from? So what do I have to do? I have
You
to
go from C.
You have to make
Go
a
from
new
C.
thing.
Okay, so I would take my ruler and I would extend this side. So I would take my ruler, extend the side, and then I could draw straight down. Oops.
That's super.
So you do that whenever.
When it's an obtuse triangle. Notice when it was an acute triangle, I could draw it straight up and down. But if it's obtuse, the altitude's gonna go
And if it's
outside.
right triangle,
It's an obtuse if the obtuse angle's down
Yeah.
here.
what if it's a right triangle?
What do you think if it's a right triangle?
And then it already works.
Then one of those perpendicular sides would be the height.
And you wanna have to do the line, please?
Nope.
Can you just do 3x plus 3 equals 90?
Good. Does an altitude say anything about midpoint?
No.
So, and also just looking at these, do these two look equal to each other?
No.
No. So all I can say is 3x plus 3 equals 90. Remember how I said we're either setting things equal to each other, or we're setting them equal to 90. Altitude.
87 divided
Thank you.
99.
Okay, what do we get?
by 29.
29. Okay, we also want to find IJ.
How did you plug them back in?
Yeah, okay, so if x is 29 and this part is x plus 8, what's this segment going to be? What's 29 plus 8?
37.
37.
Can I also just do x plus 8 equals? Oh, it doesn't.
Yeah, yeah.
Wait,
And
but does it
then-
Wait,
equal
what's
each
up?
other?
87.
37.
So then it's
plus
20.
So it'd be
This has to be
57.
20.
So you add them.
So we're
together.
gonna add those two parts together.
It'd be 57.
Good.
Oh, you equal it to 90 because it's perpendicular.
Yep.
And then what you get, and then you have to plug that in.
We plug
Is
it in.
that 57?
Because an altitude does not bisect.
Well, where do you put the 29? Where do you,
Plug 29 in here. You get
oh,
in
plus
here,
eight.
and then you can figure out the
Oh,
segment.
just plug it into both.
Yeah.
Okay.
Whoa.
All right, these are just a summary of all the important segments. So there's 4 of them. Okay, the first one we did, perpendicular bisector. We feel good about that. Makes a right angle and makes things congruent. Angle bisector just makes the angles congruent. A median goes to the midpoint, makes 2 segments equal. And an altitude makes
Alright.
a right angle.
Is this like drawing like this diagram important? It's like
What the hell is the next thing?
Oh, okay. It's okay.
Oh my god.
All right.
So what the hell is that then?
It's a picture of a triangle with lots of line segments
Oh,
and things.
no.
I know what the angle bisector is.
Okay, what I want you to do is, can you identify and
Wait,
okay.
you just have to say the
GC.
angle?
Okay, so we're looking for a right
Line
angle.
GC.
VH.
No, VH.
Okay, there is a right angle here,
VH.
but
There's
are
also-
these congruent?
No.
No.
No. So
Oh,
let's look.
GC.
GF is the perpendicular bisector.
GC.
GC.
Oh, G, I mean,
No.
G is
Yeah.
like the midpoint.
No, GC is the angle bisector.
Guys.
You gotta turn this.
No, I
Wait,
think
there's
it's
case
G.
no, it's GF.
Oh, GF. Sorry, GF. You're right. Sorry.
I felt so smart.
GF.
The angle bisector.
Yeah, the angle bisector
CG.
is CG.
But why does it have to go from C?
Because that's where the angles are.
Where's the angle start?
Yeah, right.
Yeah.
And then the median is HB. No.
The median is G.
No. B8. No.
The median is GF.
All we're looking for
Yeah,
is a
it's
mid.
AE. Oh, it's AE.
AE,
Yeah,
good.
AE.
Why is it AE?
And then the altitude is HB.
Good.
H.
Wait, how wide? Cool. This is great, perfect.
That was a little confusing of a diagram,
A
but
little.
oops. Helps if I take the clip off first.
Miss Basic, can I throw away my papers from last semester?
It's a packet.
This case, is the 9? What's the 9? Is it a weekday?
It's a Monday.
Monday?
Today?
The 9th is a Monday.
Yes. Because the 8th is a Sunday. I know that.
What's wrong, Mia?
It's already the thing, I'm wondering.
I didn't get my 2.
Perpendicular bisector to.
Oh, is this
Side,
unit gonna be
yeah.
worksheets by any chance?
Some of it will.
Is this the thing where you put the line in the middle? Or the thing in the middle?
You have math along. Yeah. Why do you have to
Okay, perpendicular bisector to DF.
I was just going down.
Yeah, you put like a line in the middle of D and F, right?